It is wonderful to be here in this second session of the season. I'm just wondering how many of you were at the October event? Okay, a good bit of you. Good. So we don't have to have too much in the way of background, but yes, I told you all in October that my name is Greg Schrock. I am a lay person in all of this. I'm fascinated with it, but I'm an accountant. I am not a scientist, theologian, anything like that. But it's super fascinating to me to be engaging in these topics, and so I asked Stu if I could kind of be involved. And so we've had some great conversations, and I am super excited about today. So welcome, Stu.
Thank you.
I've been meeting with him off and on over the weeks to try to prep for this, and I am super excited about today's topic. This one. Every topic that Stu has talked about, I'm fascinated with, but this one, when we're talking about these astronomically fine-tuned things, I think you're going to have your mind blown a few times before you leave. I hope you are, if you really understand what this is about. It's unbelievable stuff. So let's get right into it. There are a few that haven't been here before. Could you just briefly describe what Saddlebrook is all about, or Saddlebrook is all about? Socrates at Saddlebrook is all about.
Well, the first thing is we're going to change our name to Socrates of Mongolia. So,
love it.
And Saddlebrook.
Love it.
Greg is being a little humble about himself. He's a lay person like most of us are. We don't work in these fields professionally, but he's a philosopher. He's a philosopher investigator, and he runs a chapter here locally for National Philosophical Association. So this is really, since Socrates at Saddlebrook is the intersection of science, philosophy, and theology. I mean, that's really what we're trying to do. This is perfect. He delegates the science and the theology to me, and I delegate the philosophy to you. So this works out well. Socrates at Saddlebrook, as I said, is this intersection of three topics that usually aren't talked about together, except at a cocktail party or a bar room or something of that nature. And when we go off to work to talk about these kind of things, we're narrowed, we're so segmented. So, and then when the topic comes up, something as astronomical as, well, who did this? who did all this stuff? It's either, well, the people at church say one thing and the scientists say another thing. And this is an opportunity in our club here to have discussions about this. And we were really happy about going through the first 2 seasons talking about what's the science say? I mean, science is the high priesthood of our culture. That's where we always ask the scientists, what do they weigh in on? What's their report? So, well, let's look at the evidence. Let's look at this as almost a legal issue and a philosophical issue. Let's look at evidence. What can be said that we can observe. I mean, science is observing and explaining things. It's nothing really more esoteric than that. We're all scientists in that fashion. We all observe, we make conclusions, tentative conclusions. We look at evidence, and when new evidence comes in, we might change our minds. The second thing is we all have assumptions that we start with, right? We have a worldview that we start with, and we evaluate the evidence through that worldview. So we've been working through that. And if you go to the website, we have about 25 video casts that we did the first 2 seasons on a lot of scientific topics, starting with the beginning of the universe, all the way through what life is and how all these different species came here and where is it all going. So in Socrates, we do origins and destiny. We ask those big questions that we probably thought of when we were 13 years old and 17 years old, and then we forgot when we started making money and families. And that is, how do we get here? Where are we going? Why are we here? So that's Socrates at Saddlebrook.
And so the first 2 seasons, if I understand, right, that we were putting out there all of the evidence for all of this, right? I think we can all say that not everybody agrees with this. When you look at the culture today and you hear what the universities are talking about, when you listen to the media, not everybody agrees that this evidence points to where we think it points. So as I understand it, so season 3, we're taking a deeper dive into this evidence and with a cross-examining eye and to see, does this really pass muster? Can we scrutinize this, and does it stand on its own?
Well, that's what excites me about it, because we get one side of the story from the media. We only get one side, but there is another side. So we bounce back and forth, and we'd like to show both sides. So if you watch the videos, we're always like weighing, what is this, and what direction does it point? It's not just making a conclusion about a particular question. It's saying, well, does the direction point that way? Let's follow the trail wherever it leads. Let's go that way if that's where it leads. And that was with the great contribution that Socrates made to Western civilization. Well, all civilization is questions. You know, we specialize in answers, but we should specialize in questions. And questions, more fun to ask questions and let other people talk and then have a discussion. So that's what we're doing.
Absolutely. So I'll keep the summary brief because most of you were here last time, but I thought I would just go over what we accomplished in the first one. The first one, we looked at the beginning of the universe. And what does what we know about the beginning of the universe point to? What are the implications of that? And we brought up many, many scientific lines of evidence that show that the universe is not eternal. Instead, it had a beginning. That's the key point that we were trying to bring up, that the universe had a beginning. And when you think about that, the universe is all of space, all of time, all materiality, all energy. All of that started right at the beginning of the universe. That's what we mean when we say the beginning of the universe. And once we laid out that case, we talked about, well, what does that lead to? And when you think about it, it ought to lead to some cause that caused the universe that is timeless, because there was no time before the beginning of the universe, spaceless, because there was no space before that, immaterial, and unimaginably powerful, right? Whatever caused the universe had to have been powerful. And actually, we made a quick case that whatever the cause of the universe was something personal, a personal agent. And so we laid out evidence for the beginning of the universe, and then we drew a conclusion that we believe that the beginning of the universe is evidence for a creator. Okay. So, and that should be familiar to most of you who were here in October. So today's topic, we're turning to the fine-tuning evidence. Let's begin, Stu, with a definition of fine-tuning. What does that even mean? Something that's finely tuned.
Do, re, mi, fa, sol, la, ti, do. How many of you are musicians out there? Play even a ukulele? Okay, there we go. Anybody can tell me what middle C is in frequency? You know when you hear it, right? But you know it's about 216 hertz. If it's 215, you'll know it. If it's 120, you don't have any rock and roll, right? So fine-tuning is exactly that, things that have to be precisely on the button to work and to be manifested. And we're going to be talking about how planet Earth has to be precisely on the button and manifest it that way for us to even survive.
Okay, so that's a broad definition of fine-tuning. So, okay, let's bring it down to the topic at hand. Okay. So fine-tuning is something that's, I guess it's intuitive, right? That's finely tuned to a particular value. Mm-hmm. Now, you're talking about the universe, you're talking about Earth. What do you mean by saying that the Earth or the universe is finely tuned? What does that even mean? Okay,
well, this is, as you said, a fascinating topic when we first dug into it. That's why we wanted to go deeper. If you were here last time, we started off in the Milky Way, if you recall, and pointed to where we were in the Milky Way, way out there on this little star, actually a little planet that goes around a little star in all that vast Milky Way. We started out there. And today I'm going to start you off on Mars. And as you probably know, we haven't been to the moon for over 50 years. I mean, that's kind of silly, isn't it, when you think about it? We had this amazing thing back in 1969 when a computer had all the computing power in the world probably was less than this, yet we put a man on the moon at the time. So we're going to the moon next year. I think we're going to circle it. And then in 2024, I think we're going to actually land on it. And we're going to, they're planning on this Artemis missions being mid 2030. Wouldn't that be fabulous to stay alive long enough to see a Neil Armstrong on the moon? I'm kind of really hoping for that one. So I'm going to take you on we're all going to get on this we've landed on Mars, and we're in the Land Rover, and there's dust storms on Mars. You know, it's a red planet, red dust and everything, and we're in this Land Rover, and we're coming up, and obviously we haven't found any life there. We haven't found any we haven't even found water yet. We think there's water there. And we're coming up over the ridge, and this is what we see. The dust settles. The dust settles, and this is what we see, and we go, whoa. Now, what's the first question you say when you see that? How did it get there? Is anybody going to say the dust storm did it? No, nobody's going to say that. All right, we're going to say, maybe we might say, who put it there? So that's our first. Well, what do we do? We're curious. We're wired for curiosity. I mean, Aristotle just told us that's our whole life is just wired to keep on investigating. So we're going to go down inside the building there, and we're going to investigate what's going on. And the first thing we notice is the two buildings. This one on the left that you see there, we find out that that's an amazing observatory. And it's tied into a couple different sections. There's one section with all kinds of instrumentation that's pointed out toward the universe. And it's connected to something in the main building. We know that. We see cables and everything. And then we look at over here and we see this huge telescope type of thing with all kinds of instrumentation on the and what do they say inside that telescope is planet Earth. It's zeroed in on planet Earth. And we have our physicist, our resident physicist, and a resident mathematician with us. So we charge them with going and giving us a report, going and investigating what those dials are and everything. And they come back and talk to us about what those dials are. And they said, you guys won't believe this. There's a control room in that other building. And you see these green panels in the beginning here is 24, there's 24 dials that are set. And it's tied to that instrumentation that's looking out in the universe. And then on the walls there's 250 dials that are set. And that's tied into all this instrumentation on planet Earth. And this is how we're going to explore this question about fine-tuning for planet Earth today.
So you mentioned that some of the dials are attached to instruments looking out into the universe.
Yep.
And other dials are looking at Earth.
Correct.
Why don't we start with the dials that are looking into the universe?
Okay. All right. Well, there's only 24 of those.
24 dials.
So we thought those were the simplest ones. So were we mistaken on that one? But this is what we found when we looked at these dials. We found, holy mackerel! They said, you won't believe this. Those dials are set to the exact values that are necessary for the universe to exist. What do I mean by that? Well, science has discovered that there's 4 fundamental forces. They're trying to get it down to one fundamental force. But all the forces in the universe, now here's a force. Gravity. That's universal. That's just not here. That's on Mars. That's out in the universe. If it wasn't, we could never send a mission out anywhere. So gravity is fundamental to the universe. Electromagnetic force. What's electromagnetic force? Well, you have magnets. So there's pluses and minuses. Boom, plus and minus, plus plus. No. Electricity that's a force. And then inside the atom, we have two forces that make the atomic bomb, fission force. Mm-hmm. We have radioactivity, and we have something that holds the atom together. Remember from your basic science class, all those protons that are in the atom are all plus charge. Well, what holds plus charges together? I mean, plus charges should be repelling. No, they're held together. It's called a strong nuclear force. So those four constants, those four forces, and each one of those forces has some constants associated with it. What do I mean by constants? Well, all right, you probably remember your pi r squared. All right, what's that? What's pi r squared? Area of a circle. Area of a circle, right. There, area of a circle is pi r. Well, why isn't it just r squared? Well, it's just not r squared because it doesn't work, but pi r squared, 3.1414, so if we do that, that gives us the exact area. Mm. Well, all these forces are the same way. They have constants associated with experimental evidence. This is all experimental evidence that, and we find out that the gravitational force, which is called G here on this chart, this is a listing, this table here is a listing of the exact values that are required for the universe.
So each of these things on the table is a dial.
Each one of those,
each one is set.
Each one of those is set to those things.
Okay.
Imagine how mind-boggling that would be to find out, oh, here's G, 6.67430, all the way to, for 20 decimal places, it's set. And you go, whoa. So G is that, E, the electrostatic force, is that. These are the fundamental constants of nature that we found to be wired to that instrumentation.
So the dials are all set.
All dials are all set.
What happens if one of those is off a little bit?
You don't want to find out.
Does the tea taste different or something else? What's going on?
That's a good question. Some of them are within a few percent. They can be kind of wiggled within a few percent. Some of them are so precise that you don't even want to think about it. One value, let's say if it was just a hair breadth off, the universe would disintegrate, like the value of G. The value of the gravitational constant, the strong nuclear force, if that was off, the atoms would just explode. So that's why it's so important to understand that the universe is fine-tuned by these precise values that we had nothing to do with.
They just are baked into the universe.
They're just baked into it.
And so G equals 6.67430, but if it was 6.67430, 05, you're saying that
we wouldn't be here.
We wouldn't be here.
This has to be, in fact, G has to be fine-tuned to 1 in what they say 10 to the 35. What's that mean? That means 1 in 35 zeros.
One part.
One part.
10 to the 35th.
One part in 35.
In other words, quite precise.
If it's off, things, well, like the sun, for example. The sun has, how the sun works is it's a million nuclear bombs. Hydrogen bombs going off, converting hydrogen into helium. So that's pushing all these explosions, and that's governed by the electromagnetic constant. The gravitational constant is pulling it together. So you have a flaming furnace up there of a billion or so hydrogen bombs going off every second. And if one of them was off, it would either go or either way, we wouldn't be here.
I'm going to appreciate tomorrow's sunrise a little bit more now. Thank you, Stu. Wow. So you, how many of these dials are there that are pointed towards the universe?
24, but in this building, right?
Okay, and each one is precisely
each
tuned.
one.
Okay.
Each one.
So then you talked about 250 dials pointed pointed towards Earth instead of pointed toward the universe. So does that imply that the Earth is somehow finely tuned as well?
Let me just show you on this. These are perfectly set. So G is tuned to 1 part in 100 billion trillion 10 to the 35 power Just to give you some idea of what impossible is on a practical sense, impossible on a practical sense is winning the Powerball jackpot is 1 in 300 million. And if you did that 6 times in a row, you'd be at the impossible level. So that's kind of a practical impossible. Just to give you some idea of that we're fine-tuned with these things to a knife edge, is what physicists say. We're fine-tuned on a knife edge. But you wanted to get into what the idea of the 250 is. And I'm going to have to do a little explanation here for the 250. I'll have to take you on a little tour of what these 250 dials are, because this is just strictly for planet Earth now. We get down from the universe, we're bringing it down to planet Earth. And as we learned last time, the Big Bang, the universe, which was almost an infinite chaos of heat and energy at the very beginning, it was exploded. It wasn't even an explosion. It was just an occurrence, a miraculous occurrence. Physicists have no idea what caused the Big Bang. Theologians, very easy for a theologian, right? I mean, I'm a Christian, so I have no trouble saying in the beginning God created that. But we're talking about science here, and what does science say? Well, science says we started with a small dot of explosion, but all the universe, everything, including all the atoms in our body, everything we see around was contained in that little ball of almost infinite small size and almost infinite energy. And it expands. So the Big Bang means really an expansion from that very beginning. And we talked last time about how that was discovered. Hubble at Mount Wilson back in the 1920s, looked at the universe. We thought that everything was just static, like you said, an infinite universe, and was just static. No, it's expanding. It's going. In fact, it's expanding every day. It's tomorrow it'll be even space-time fabric, just that keeps on expanding. So a Belgian priest by the name of Montre, we talked about him last time. He ran Einstein's general relativity equations, which actually model this. And he ran them backwards, and he said, well, if it's expanding, it must have, yesterday it was smaller, and yesterday it got back to the very, very beginning. So that's when the Big Bang. So what happened from the Big Bang to planet Earth? Well, there's a 10 billion year time frame here. This is what science is telling us with a lot of experimental and empirical evidence that the atoms came together finally when the universe started cooling down. At the protons and the electrons, remember that old atom that you saw and everything, they have electrons in orbitals around the nucleus. They formed the first simple element, which was hydrogen. Hydrogen is just the simplest thing. And then hydrogen and helium. Helium is the next one. And then we have 92 elements, from that chart on the wall that you used to see, that chart on the wall. We have all the metals and so forth. And they get manufactured over this 10 billion year period. Now, how do they get manufactured? Inside stars. So gravity collapses these stars, and as they collapse, they add more protons, so higher order elements get formed in there inside the stars. The stars are actually not only nuclear forces, but they're the manufacturing agent for all the materials. All the matter in the universe is manufactured inside stars. And we can see this today. It's really exciting to see new stars born. He's an amateur astronomer too, and I love that. We look at the stars, and you can actually look at star-forming regions to see the stars. And then you can tell what's inside the stars, what elements are inside the stars by what they call their spectrum. Just like we see the red, orange, yellow, green, every element has a signature. And since every element that's here is out there, it's uniform throughout the universe, there's no disuniformity on that, we can know what the elements are. So we go from the stars to the elements, and then what happens with the elements, now that you have elements, now you have some materials, you have some metals, you have dust, you have gases and so forth, and that's what we see up in the sky. That's what Hubble first saw. He thought that, what is that fuzzy thing? Well, it's a bunch of dust clouds. They called them nebula. They didn't know what nebula were. But then we started looking closer and closer as we got bigger telescopes. We have the Webb telescope now. We see to the end of the universe.
Unbelievable.
For Pete's sake. It's amazing what we see out there. And all that stuff was all the way back in the very beginning Big Bang. So the galaxies form. Then the galaxies form. And there's all kinds of different galaxies. There's spiral galaxies like our Milky Way that have big arms on them. There's elliptical galaxies like Andromeda that are together, packed together. There's global, globular galaxies that are different. Ours happens to be a spiral galaxy. And then from that spiral galaxy, things just like a merry-go-round whip off. Material whips off and then starts cooling down. And as it cools down, then all of a sudden one of the stars starts cooling down, and it has stuff whipping around it, and that's the formation of the planets. And as that cools down, the planets cool down, and then they circle, they become the solar system.
All obeying gravity.
All obeying
right?
gravity, exactly.
Yep.
Cool. You know, the thermodynamics, which is the thermal properties of it, and gravity, and it all collapses down, and then eventually there's the little planet Earth collapses down.
Okay.
And 4.5 billion years ago, there's our planet Earth.
Amazing.
So the Earth was born 4.5 billion years ago, according to our scientific evidence. And look at it there in the left frame there. It was just, molten gravity, gravity and molten material. And if you look carefully, you can see things bombarding, coming in. That's asteroids and comets, and even little planetoids are coming in there. Some of those planetoids contain massive amounts of water. Water's one of the most prevalent molecules in the whole universe, next to hydrogen and helium. It's H2O. Remember that? Yeah. And so all that water was carried on, and then we go from a phase from molten magma to being covered with water, and then voila, dry land appears about 4.5 billion years ago. So
you've taken us from the Big Bang all the way to now we've got the Earth.
Now we got the Earth.
Okay.
Now we got the Earth. So how does that apply to fine-tuning? Well, you'll hear me talk about just right. Remember the story of Goldilocks and the three bears? So what did Goldilocks do when she found the cabin and started tasting the oatmeal?
Porridge.
Oh, was it porridge?
It was porridge.
Well, you still have younger kids than I do. Porridge. What was she doing when she was sampling the porridge? Testing the temperature. Yeah, she's testing it, right. What is she finding out? Yeah, there you go. Too hot, too cold. And what was baby bears? There, just right.
Just right.
Just right. Well, she's fine-tuned. I mean, she was doing scientific testing. Okay. She was saying, I want the one that's just right for me, right? It's just right. And that's what's happening to all these different things that are happening in that big 10 billion year time frame. We find out that we're in the just right type of galaxy. The just right type of solar system. What does that mean? Well, Jupiter and Saturn, for example, big planets. I mean, this is huge. Earth's like this, They're like giant vacuum cleaners. They sweep around the sun and clear out all the debris that's coming in from outer space. They protect the Earth. They're the guardians of the Earth. You have to. That's a just right condition. If they weren't there, we wouldn't be here. We'd be bombarded by outside asteroids. Well, not asteroids, but comets. And so forth. We just had one a couple weeks ago or months ago, I think it was, that passed between us and the moon. An object, I mean, it wiped out. They finally discovered it when it was just not that far away. This sounds like science fiction, but this is real stuff. This thing could, if it hit, would have wiped out a whole city. So
what you just said is that if we didn't have these larger planets in our solar system, life could not have arisen on Earth?
Life wouldn't be here.
Because we would have been bombarded too frequently for life to really get going. Is that what?
Exactly.
Okay.
Just right porridge on that one. And then the habitable, these are referred to as habitable zones. there's 13 habitable zones. What does that mean? Well, it has to be in the just right zone or something's going to happen. I mean, think about this one picture here on the right with the green belt. We're 93 million miles from the Earth, from the sun. And if we were any closer, we'd burn up. If we were any farther away, it'd be too cold. There's only a 2% variation in there to have
2%.
2%. You know, we worry about climate change. To turn that dial just a fraction, 0.1%, that would wipe out all the climate change problems. And 2% would put us out of business altogether.
Well, we already have experiments, right? I mean, Venus has no life.
There you go.
Too close to the sun.
Exactly.
Mars doesn't have any life. It's too far away from the sun.
Exactly.
We're in the perfect place.
And that's a great illustration. I mean, we know these facts because we've been there. We've sent exploration there. We know what the surface temperatures are at both of those places. And then in the lower corner there at the moon, we need a just right moon. Why do you need a just right moon? Well, our moon combination is so extraordinary. So extraordinary. It's the combination of mass between our Earth and the moon is like 50 times what any other kind of any other planet is. Well, why is that important? Well, we're tilted at 23.5 degrees. You know, all the globes. You have one there. You're all tilted like this. What does that do for? What does the tilt of the Earth do for us?
Gives us the seasons, right?
Seasons, yeah, absolutely. I mean, and so we need seasons. We need a cycle. So we can't just keep on living in the same condition all the time. That would be locked into something. I mean, it'd be like living in Palm Springs all the time, right? in the middle of summer. I mean, or here, I should say, all the time. If we didn't have a winter season, we wouldn't have any snowbirds. Jeez.
None of you would exist without a 23-degree tilt of the Earth. Wow. But what you're saying, Stu, is that the tilt of the Earth is finely tuned. I mean,
it's tilted. If it was any other variation, if it was straight, like Mars is like this, and it flops back and forth, ours stays stable all the time because of this big moon. I mean, this big moon stabilizes.
So the moon stabilizes that tilt.
It stabilizes.
If we didn't have the moon, our tilt would be variable,
all over the place.
And then life could not have arisen.
Exactly.
Wow.
Some of the planets are, lying on their side.
Yeah. And getting back to the dials, this is one of those 250 dials, is what you're saying.
Exactly.
Okay.
Yep.
Just one.
Just one of the dials.
Okay. We don't have time for the other 249, but it's amazing how finely tuned the Earth is.
And the last one I have on this picture here is the magnetic field. We kind of take that for granted. We don't think about the cosmic ray bombardment from what's going on at the sun. I mean, you worry about a little suntan and a little sunscreen. If we didn't have the protection of the Earth's magnetic field, where'd the magnetic field come from? Anybody? Where's the magnetic field for the Earth come from?
I think somebody said it, right?
The core of the Earth,
the iron
right?
core of the Earth,
core.
Right?
It's a magnet. It produces, and magnetic field, and running through any electrical conductivity running through a magnetic field produces a shield, produces a field. That magnetic field shields us from this cosmic rays bombardment from the sun. That's highly fine-tuned. And there's been cycles over the periods of time. The sun has... Anyway, these are just some of the just right conditions for the solar system.
Okay. Just right for the planet Earth. The water cycle, photosynthesis.
We're only out in space here.
Dial.
We haven't even gotten to the surface here. Now we're going to get down to the surface.
Wow.
Ready
Amazing.
for that one?
Let's go for it.
Oh, okay. All right. Well, there's your, on the upper left-hand corner there's your perfect fine-tuned Earth with a magnetic, with iron core that produces this has the right kind of crust. You know, we don't think about these tectonic, we lived in California for most of our lives, and earthquake come us. If we could only control the earth, you don't want to control the earthquake totally. You need to control. You need what the earthquake we need to survive, because the nutrients in the shield of the crust of the earth need to be recycled, and the heat, the radioactive, there's uranium and everything, and atoms disintegrating into there. There's heat that needs to. Volcanoes need to happen. It's sad that people have to die in these natural things, but we would all die if
we never would have existed if we
wouldn't
have
even exist.
Yeah. Yep. Amazing.
Exactly. So we have the just right conditions for the Earth geometry, and then we have the just right conditions for the water and land. We couldn't be all water. Fish don't do telescopes. So we need a rocky planet. You hear about looking for life in outer space and so forth. First thing to look for on another planet, is it a rocky planet? We need a rocky planet, but we need a water supply. I mean, the most important thing we find is water supply. Is there water there? So we have the just right conditions for that, the balance between 70% of water and 30% land. And then we have the just right atmosphere. I mean, that atmosphere is so fine-tuned, so fine-tuned. If it wasn't 21% oxygen, just within a few percentage points, if it was more oxygen than that, I mean, let's say it went up to 30%, for example, you'd light a match and boom, a lightning strike would just not cause a forest fire. It would cause an earth fire. We'd be
the atmosphere would burn up, in other words. Wow.
If it was less than that, then we'd be in a situation where we couldn't breathe. I mean, and we wouldn't have photosynthesis. And photosynthesis, you remember that? We exhale carbon dioxide. The plants take in the carbon dioxide, and they use that energy, and then they put oxygen out. And I mean, it's an amazing cycle. If that was out of sight, and then the water cycle. I mean, once you have if we didn't get thunderstorms, if we didn't have clouds, if we didn't have, and that's all fine. Those are some of the dials as well.
Well, I've actually heard that the Earth is extremely rare because water exists in all 3 states on this planet.
There you go.
And we haven't found another place where that happens, and life is dependent on all 3 states of water. It's another one of those things that's finely tuned.
Miracle molecule. Just study, if you want to have one study, just find out what water does for us. I mean, all the way from blood supply to cooling, and only because of its physical properties. Yeah. Even fish would die if water didn't have a unique capacity that when it froze, it rose. It actually, the solid float, so that we have ice on top of the pond, instead of falling to the bottom of the pond, all the fish would die. So. Wow. That's something. And then carbon dioxide, I have to leave it with carbon. There's only one molecule that can bind all these molecules together, and that's carbon. We need to have carbon. And carbon needs nitrogen, and it needs oxygen, and it needs it in that exact just right supply.
Amazing. So we've gone over, I think you've convinced me, Stu, that there's fine-tuned things out there, these constants and quantities of the universe, but also all of these characteristics of our galaxy, of the solar system, of the planet Earth itself, and everything, all conspiring, I guess you could say, so that life like us could sit in a room like this and ponder such questions, right? I think you've convinced me that actually does exist. So Socrates at Saddlebrook talks about trying to explain this. Okay, we've laid out the evidence. Now, are you saying that this is what you have said, that intelligent design is perhaps the best explanation for this? What you hear out there, though, is that this just happened. This just happened by chance. Natural forces, unguided, undirected, just made the things the way they are. And I'm wondering, can this happen by chance? I mean, maybe we're really lucky.
Yeah, maybe we won the cosmic lottery.
Maybe we won the cosmic lottery. 50 times in a row, but maybe we did, yes. So what do you think about chance?
Well, that question is not asked. That question is just assumed, right? I mean, it's called materialism, and it's the way science is conducted. Science doesn't demand those kind of answers, chance plus natural law. Chance and plus natural law are important, but what's the missing component that does the fine-tuning? And that's where intelligent design comes in.
Okay.
And I'll give you an example of why that's absolutely necessary. We didn't talk about the values of these 250 parameters for just right planet Earth. I'm just going to take one of them.
Okay.
One value that from the Big Bang to planet Earth requires that the information that's in the Big Bang from the very beginning has to be finely tuned to a very precise number. And I'm going to show you what that number is, Greg, and I'm going to do it by giving you money.
Okay.
We're going to start with pennies. But I'm going to give you a chance at the lottery for, I think it's worth about $150 right now.
Okay.
So you up for it?
I'm game.
You up for it? Okay. All right. All right. I'm going to give you a stack of pennies here. We'll start with 10 pennies. All right. I'm going to count them out, and I'm going to put them in a pile here. All right?
Yep.
Now, one of those pennies is a 1931 S.
Okay.
The San Francisco Mint, Lincoln penny, worth about $150 today. So there's one of those in that stack.
Okay.
I want you to pick one and see what you get.
What
are your chances, first of all?
Well, how many are 10? 1 in 10.
1 in 10, okay.
10%.
You pick one.
Okay. Okay. What did you say? 1938?
31.
S? 31, S.
Is that yours?
That's the one I picked?
Oh, darn, I lost. Now, the chances were 9 out of 10 that I would win. No. Okay, well, we're going to play this one more time, all right?
Okay.
It's not even going to be double or nothing. I'm just going to really have fun with you this time.
Okay.
I'm going to give you a stack of pennies that is 10 billion pennies. High.
Billion with a B.
10 billion with a B.
Okay.
You better keep on. 100,000 miles high. Would that be that? 100,000. Now, but I'm going to put a more valuable penny in there this time.
Okay.
That's a 1943 D penny, copper penny. You guys remember what pennies look like in 1943? Some of you probably do. Even today, you see those steel pennies. You know, they're not copper. This penny was worth $2 million at the last auction. So
now we're talking. Okay. All right.
But this time you have to pull this out randomly out of 100,000 miles, 10,000 miles high.
10,000 miles
high
of pennies.
Of pennies, right?
Okay. All right. Well, I have to pick one at the bottom because I can't get way up there. So here we go. 1943. D.
Oh, no. You didn't do it again.
I just picked
No.
1943.
Oh, now I'm really out.
Okay.
But I'm really not, because I'm really kidding with it, because now you have to do it 122 times more in a row.
I have to pick that one penny
That
122 times over and over again.
Yeah.
It's like winning the lottery, essentially.
It's way beyond any imagination. And this is called the initial entropy of the universe. What does that mean? I mean, to get all the order we have today that we see, we had to have all that placed back into this little ball of energy in the beginning. And it could be all over the place, but it had to have the order. If we're going to have order today, it had to have that order baked into it from the very beginning. Wow. And that's what's called the initial entropy of the universe. That's just one of the 250 variables.
That's just one?
Just one,
Okay.
one of them. So anyway, one chance, scientists say it's one chance, 10 billion to the 123rd power. So
123 zeros after the 10.
It's way beyond that.
Okay.
Yeah, way beyond that. There's 10 billion, and then you have multiply 10 billion times 10 billion times 10 billion, 123 times. There's not enough atoms in the universe to contain all the zeros.
Wow. Okay.
That's fine-tuned.
That's fine-tuned.
Fred Hoyle was the Cambridge astronomer and world-famous astronomer in the late 20th century, and he didn't believe in big bangs. He didn't believe in God. He was an atheist, and he did these calculations and did some amazing things by trying to find out the theory of how this would work on its own. On something called the steady state theory, which was an alternative to the Big Bang theory. And he just came away mind-boggled. I mean, he says a common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as with chemistry and biology. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. So anybody who's serious that looks into this from that perspective of fine-tuning comes to this conclusion.
And he was an atheist, as it says there.
He was an atheist. He had no.
But
in fact, he was against Big Bang cosmology until the late 1990s, when the Big Bang finally had that last part of cosmic background radiation, microwave background that we talked about last time.
Wow. Amazing stuff. And so I know you had the slide. We probably have to move on, but I know you even had a slide of a tornado hitting a junkyard.
Oh, I wanted to talk about that.
Okay.
Well,
Why don't you talk about that?
Talk about
Y'all
that
want to hear what happens when a tornado hits a junkyard?
Oh.
Okay. Let's go.
Well, what I wanted to do is I wanted to compare how science is done in something called materialism. Materialism means that matter is all there is. There is no possibility of anything invisible, no possibility of even considering God, nothing transcendental, we call it, nothing beyond the universe, and we've talked about that before. So this new science of intelligent design says, wait a minute, chance, materialism only has chance and natural selection, natural laws. That's all these natural laws to work with. It can't do anything more than that. And now we're saying this fine-tuning brings in, how do you explain that? Well, it's either winning the cosmic lottery at the odds that we're talking about.
The odds are too great for that.
So mind-boggling. It's beyond question. Even Fred Hoyle says this is beyond question if you take that seriously.
Yeah.
So intelligent design comes along and says, wait a minute. We know what intelligence can do. Intelligence can start something. It's new. Intelligence can bring to bear design and purpose to things that natural law can't do. I mean, rocks can't come up with design and purpose, has no foresight, has no way of looking at it. So I'd always like to explain the difference between materialism, what it can do, and what intelligent design added to that can do. And thank you for remembering that I had these slides of a tornado as an example.
Okay.
So, all right, tornadoes. Natural law and chance explains tornadoes, right? You need a body of water. You need some warm air, humid air rising. You need thunderclouds. You need warm air rising up. You need cold air coming down and intersecting by chance and swirls. And it keeps on swirling and then eventually forms this tube. Right?
Perfectly good naturalistic explanation.
Perfect.
For it. Yes.
So we don't need anything, any intelligence behind this at all. All right. So we have all the materials. We have the ocean there. We have air. We have water and gravity. But what happens when the tornado hits the land? Doesn't have all the features, all the materials it needs. It doesn't have the ocean for one thing. I mean, it'll start dying, it burns out, right? It starts dying out. So I'm going to do a little thought experiment with us here, and I'm going to say, let's keep this tornado going, and then figure out how to keep it going. And here's what it does. The tornado keeps on going, and it happens to pass over top of a junkyard. So there it is. It's swirling up the junkyard. But look what's coming out of the junkyard. A Boeing 747. Possible, right? I mean, anything's impossible except squeezing toothpaste back into a tube, right? Anything's possible. Why isn't that possible? That's what a materialistic explanation could not possibly answer that question, right? Unless you're going to say it chance or natural law. Well, we have the natural law. We have the tornado there. No. We have the chance of the junkyard. But is that anybody actually believe that Boeing 747 is going to be was
randomly produced by the tornado hitting the junkyard? Who's
going to believe that? Nobody. And it's not going to happen. No. So how could it possibly happen? Well, there's design and purpose. We know it matches, that 747 matches something we know something about. What do we know about it? Well, we know it was created by Boeing. We know there was 50,000 engineers or whatever. We know there was a manufacturing facility. We know there was billions of dollars put into R&D. We go on and on. Minds did it. Minds did it. It didn't happen by natural law and chance. There was minds that had design and purpose in mind.
What you're talking about is the hallmarks of design.
Hallmarks
right?
of it.
You know that you look at something and you know intuitively that it was designed.
You know it intuitively, and even now science can show that. And how science can show that is by matching what the result is against something that independently we know has been designed for a purpose.
So you're introducing purpose, and we can recognize purpose.
We can recognize purpose,
right?
We can recognize design because it matches this specification, that 747 matches what we know something about already. And we say, well, geez, there's some design and purpose to that. There's intelligent design.
Excellent. There are some explanations floating out there for this. Okay?
Yes.
And one of them I've heard does have to do with the Copernican principle that you just had up on your slide. And another one is something called the multiverse. And I know it's getting to the top of the hour, but I wonder if you could briefly bring up both of these and explain why they may not work to explain the fine-tuning.
Well, this is the one side of the story. You watch PBS stations, you watch, you look at your college textbooks, you look at what your kids and your grandkids are learning in school, and you'll learn something like called the Copernican principle. And this was based on, in the 20th century, we started looking out in the universe and we said, the Earth is really insignificant. I mean, it's this tiny speck in this tiny corner of the universe. The sun is like nothing compared to all the other stars.
Because the universe is so big, so vast.
This is a little speck of dust.
Yeah.
And in some and then this was popularized by Carl Sagan, the famous astronomer in the last 80s and so forth. And it became really popular with Voyager, when Voyager went out past Pluto. And they turned its telescope around, and it caught this picture of Earth in this ray of sunlight there, that little speck there from 4 billion miles away. And it just said, Earth's insignificant. Mankind's insignificant. We're just this lucky accident. It's a delusion for you to think that you're special. It's a delusion to think that the Earth is special. It's a delusion to think mankind is special. It doesn't, we don't have any kind of explanation for it, but there's an infinite number of possibilities. So how could you possibly think that you're special? And but that's not an explanation. That's just the criticism, right?
You're right.
So the explanation was, if we're not just the lucky winner in the cosmic lottery, there must be billions, trillions of other universes out there. And if we're not we just happen to be the right one. And that's what the favorite explanation is among physicists today. Now, when I say favorite, I mean maybe a personal favorite because there's no science, real heavy-duty science behind it, but that's where they take us. So I wanted to introduce that to everybody.
And you're talking now about the multiverse.
I'm talking now about the multiverse.
Oh, okay.
Yeah. So the multiverse is if you have all these different universes, and so what I'm going to do to wrap up here, I'm going to say, is it why we've arrived at our conclusion in Socrates last season is because what's a better explanation? Is multiverse or a creator? So it's one creator or multiverse. There's several levels of explanation here. There's the metaphysical explanation, which means it's not physical. There's something beyond physics that's going on. But the multiverse is a metaphysical explanation. So why isn't the creator explanation allowed at the table for discussion? I mean, they're both metaphysical explanations, but which garners the best evidence? That's what we asked, and we came up with the multiverse doesn't have the evidence on its side because it's not. There's no evidence for it whatsoever, and in principle, there can't be any evidence for it because we can't even put instrumentation. We don't know where to look. There's nothing, there's no footprint, there's no fingerprint on this universe. Now, maybe there is a fingerprint, but then we'd have to find that fingerprint.
Okay.
And then that's how science works. If somebody finds a fingerprint for a universe impinging on us. But
so am I understanding that right now, because I've heard this, the multiverse is the current rebuttal to fine-tuning.
Yes.
That's where it is.
Yes.
But what you're saying is that almost by definition, there is no evidence for a multiverse because there is an event horizon beyond which we can't see. We're stuck in this universe.
Yes. And it has to be in this universe. We don't know what goes on in other universes if they exist, but if they don't impinge on us, it doesn't mean anything to us, right?
Okay.
So if there is an impingement from another universe, multi-universe on us at all, that's going to require some kind of universe-generating machine, right, that creates us and creates a... So we just push the problem up to another level, which itself would require fine-tuning.
Because whatever created these billions of universes itself had to be finely tuned to create these universes, is what you're saying.
Exactly.
Yeah.
Exactly.
Okay.
So it would be subject. The only thing that really holds to it is obscure mathematics like string theory and inflationary cosmology, which I'm not obviously going to get into and everything. There's nothing wrong with having hypotheses like this that come out of mathematics.
Sure.
I mean, Einstein started with a mathematical formula, and look at the great things that he discovered. But once you have this mathematics, you have to garner some evidence for it and show how it works. We don't have any idea how string theory. In the 80s, string theory was, we're going to answer. Stephen Hawking spent all his life trying to put together an inflationary cosmology using string theory, and didn't get there. But even if he did get there, in a theory of everything, what caused the everything? What caused the initial thing? So
right.
Either our universe is this lucky winner in this cosmic lottery that we talked about and how improbable that is, or we're going to need some evidence for it. And then I'll wrap it up with this. All possible universes is kind of a cop-out. I mean, if everything is possible, that's no explanation. There's no explanation if everything is possible, right? So we have to look at balancing here, one creator versus near infinite number of universes. And science always opts for the least, the simpler explanation. It's called Occam's razor. Right? It's, you don't multiply. Once you have an explanation, you don't keep on multiplying causes and making it more complex and more complex. That sounds like, they didn't get it right in the beginning. They didn't get it right, so they have to add this. And there's all kinds of things like that throughout science. But the most fascinating thing to me that's come out of this investigation is we don't need that Mars experiment to know this. We don't need to come over the hill and all of a sudden say, how did that get here? We have that right here. Just look outside. All the instrumentation, all the things that we attributed to dials and everything on Mars are already happening right here.
We've discovered these things.
We've discovered all these things already. So
what's amazing is this is something that's happened in the last 50, 60, 70 years in science.
Yes.
Prior to that, humanity had no idea that things were so finely tuned.
that's a very good point.
And now we talk about fine-tuning that, when we talk about 10 to the 123, we all understand what that can be written as, but our minds can't comprehend what one part in that many possibilities is. We just can't comprehend it. And that's just one of the factors that you said of the 250. Well, I want to make sure we have time for questions. But first, I thought it would be good for me to give a summary of what I heard and see if this is right, just to kind of bring it all home. So first of all, you made the case that the universe is extremely finely tuned, with initial constants and quantities that were kind of baked into the universe at the very beginning, that are extremely, exquisitely fine-tuned, so that 4.5 billion years later or 10 billion years later, somebody like us could arise. Okay? You also made a case that the Earth is extremely finely tuned, to the point of there's 250 of these little dials that had to be all right. Otherwise, Earth couldn't support life of any kind, right? Any one of these factors makes it extremely improbable, but isn't it really true to say that if you take all of these together, it can be truly said that it's impossible by chance alone? Okay. And as a matter of fact, I just heard a podcast yesterday about a guy who actually mathematically calculated what the outer limit of possibilities are, and we're far past that. So we can say it's impossible that this all exists by chance alone. You said that the multiverse, which is this idea where there's an infinite number of other universes, that can't explain the fine-tuning, because first of all, there's no evidence whatsoever of the multiverse, but also that if there are a multitude of infinite number of universes, whatever generated those universes had to itself be finely tuned. So you don't get rid of the fine-tuning. Okay? And then you made the case that the best explanation for the fine-tuning is intelligent design. That's what you said. Now, you didn't get into this so much, but I know that we've talked about this a lot. The fine-tuning, the intelligent design movement basically seeks to discover the aspects of the universe that show hallmark of design. That's what it's for, correct? But unfortunately, and if you were here in October, we talked about how people up front have an assumption that there is nothing beyond materialism, and therefore they jump to these almost impossible situations like the multiverse. Okay, but we can recognize design. We can recognize design and purpose. Just like that 747 is flying out of a junkyard. There is no way that a tornado put that together, because that 747 was put together for a purpose, and that is to fly people from here to London, right? It's got purpose. Okay. And then finally, again, this is something that me and you have talked about. This is making a cumulative case that the creator hypothesis deserves a place at the table of ideas. So when we're talking in the university, we're talking with academics, instead of putting all of the design stuff away, that should be on the table of ideas.
Well, yeah, like when I was in physics, curriculum and everything, that was done in another building. If you wanted to talk about a creator hypothesis or something like that, go over to the philosophy department or the theology department. That's where they talk about those things. But that's not real. Science wants to explain the truth. There is such a thing as truth. So science is really limiting himself by not putting those hypotheses on the table. And if it's going to put a multi-universe on the table, it could put a creator hypothesis right on the table too, and discuss it. Nobody's forcing anybody into a religion or what God is it or whatever. That's not even the issue. But was it designed or not is the question.
And me and you think it was.
Yes.
But at the very least, anybody should be open to the fact that that's one hypothesis
open.
among many, and it should be discussed, and we should follow the evidence with an open mind where it leads.
Wherever it leads. That's what Socrates said.
That's what, absolutely. Well, good. We're a little bit past the top of the hour, but I wanted to make sure we had some time for questions. We already have one hand up, so.
Okay, here's my question. I just want to make sure that I'm understanding you properly when you say the term multiverse. So I'm going to tell you what I heard, and you tell me if I'm right or wrong, okay? So I'm thinking that when you say multiverse, new term to me, you're saying that there's a theory out there that, well, there's the possibility, or there's an infinite number or very, very many universes, so therefore ours is one of millions, and therefore why not? Is that what the term multiverse, or the theory,
Perfect.
is that what that means?
Yeah, perfect. You heard exactly correct. That's what the modern physics says on the other side of the creator argument, that there's infinite number, near infinite number of other universes. So why do you think you're so special? And you're absolutely right.
Well, that brings up the second question. Can I ask you a question?
Go for it.
Absolutely.
Ask two questions? Okay. So here's an idea I had decades ago, and I've sort of brought it along with me in my life. But I sort of always thought that perhaps our little scientific areas, you know, with all the different aspects of science that we study, is really only we're just little tiny minds learning about God. And we're seeing a little bit, and I'm also theorizing, just came up with this on my own, I think, that if there is a God, and I think there is, then there must be only one, and we all must be worshiping the same thing, and it must be a great, 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 great mind that's way beyond my understanding. Sort of along the lines of, if God was great enough for my understanding, he wouldn't be great enough for my needs.
Well, yes, last time we did talk about what the characteristics of God would be, beyond even a creator. You have to be immaterial, because he couldn't be subject to the laws of the universe. If we got a question last time, who created God, for example? Well, God is not created. He's eternal. I mean, there has to be, and if there isn't anything eternal, then nothing could exist. So there has to be something transcendent beyond the universe. So you're absolutely right. Now, which God is it? That's a theological question. We might take that one up next season. That'd be fun. But there's one God. There's the monotheistic religions of Western civilization. There's the pantheistic religions of Eastern. That's a fascinating topic too. And it all comes, and all that can be differentiated. But that's not what the fine-tuning is a question about.
But it's fair to say, Stu, am I right, that the fine-tuning gets you to an intelligence. That's as far as it goes. And then there's other evidence that take you, well, what kind of intelligence? Is this that there is a mind, that's where we are now, but there's other evidences out there, which is not today's topic, but it's definitely out there. Well, what does that intelligence look like? And that would be a topic for another time. But yes, you're right. This is strong evidence for at least an intelligence.
So that leads into a question that somebody handed me in the back. I understand the fine-tuning for our kind of life, and I kind of understand the multiverse concept and how it might not be true. But somewhere else in our universe, there may be conditions that don't favor our kind of life, but there may be some other kind of life. Can you address this issue?
No, that's really a good one. I'd be kind of disappointed if that one didn't come up. It's like when I talk to junior hires, the first question is, where'd the dinosaurs come from, right? You talk to an adult, how about E.T.? Isn't E.T. out there? Well, and I'd love to chat about that one, but to answer the question specifically about other kinds of creatures, everything in this universe has to be subject to that fine-tuning laws that we've talked about, those 24 dials. There can't be things outside of those 24 dials. So as far as we know, as I said, we don't know anything beyond what we see out there. But as far as we can see, the 92 elements are there. The radioactive decay of these elements is the same. Everything about carbon is the same. So anything out in the universe, no matter how far it is, would have to conform to those 24 characteristics. And so there isn't anything out there that's so weird that in science fiction there is all the time. I mean, Star Trek and all these other things have given us a perverted sense of what's possible, but nothing is possible that's outside of what those dials are set to.
And what struck me about something you said, Stu, is that if these dials weren't precisely tuned, it's not just that we would have a different kind of life, there would be no chemistry.
Yeah.
I mean, no planets for any kind of life of any sort but you can't obviously have life if there's no chemistry. That's what this is contingent upon.
That's why science is so neat, because chemistry, like Greg's talking about, are atoms coming together to make elements or to make life, and they have to operate a certain way. They just don't randomly do something different all the time. I mean, it's constant. The sun comes up constant every morning. The atoms put together perfectly constant all the time. It's very consistent, right?
Other questions or comments?
Conversation.
Go for it.
I know this is rude. Okay, so if I can say, well, yeah, there's a creator, and he uses science. He created science, by the way, and so he created a flower, and he created a universe, and he created man. Okay, so, and everything else. Okay, living things. So let's say my belief just happens to be that there is a creator and God created all living things. I call it God, but you can call it whatever the hell you want. I don't care. Here's my question, though, isn't it rather arrogant and egotistical of us human beings to think that, well, if God created us, we're all there is? I mean, couldn't God have created lots of other living things, maybe on other planets, maybe at other times, maybe out there that we just quite haven't discovered yet? But it's sort of, I see this in philosophical discussions, I oftentimes see this arrogance or egotisticalness, thinking that, well, we're the greatest thing God ever created. Well, maybe we're created by God, but there's other things. Do you understand my point?
Oh, absolutely. Especially in this day and age, right? Especially in this day and age. Well, God, we're not limiting God to create other universes with other kinds of beings. I'd be, he could do anything he wants. I mean, he's God. So there could be other universes, but those universes don't exist here. Right. They don't exist here. So, and your argument, your point, it's not even an argument, but it was exactly what Carl Sagan was saying. Isn't it egotistical of man that we think that we're something special? That we think we're something special. And all I'm saying is that the evidence shows from a fine-tuning standpoint that we really are special. Now,
I think it was one of many specials, just like God created a rose in my backyard. That's very special.
Yeah. And the roses are going to grow next year just like they grew this year. And they're going to keep on going, and they're going to obey the same laws of physics and chemistry, and so they really are special. And from a Christian standpoint, you mentioned being a Christian, that's the whole point of being a Christian, that you've been created as a special person. You are special. So I'll turn the whole argument around and say that yes, in a theological sense, we are special. And if he has other special universes for other special people, fabulous. I don't know anything about it.
We probably won't. For a long, long, long time.
So today's main takeaway is that you are all special.
Anybody else? Comments or questions? Well, thank you again.